So let's take a look at Newton's second law. Remember Newton's first law, the law of inertia we just talked about. Now we're going to look at Newton's second law, and it has to do with the relationship between force, mass, and acceleration. So we are going to take a look at that equation and look at some examples of it. In essence, Newton's second law simply states the acceleration of an object is directly proportional to the net external force acting on the object. The acceleration is also inversely proportional to the object's mass. And you all know force equals mass times acceleration, that equation. We're going to look into the dynamics of that, but essentially this is stating that the acceleration is directly proportional to the net external force, and the acceleration is inversely proportional to the mass, and that's where we get this equation. So let's take a look at this mathematical relationship and think about it in terms of how the real world works. You know that if you exert a small force on an object, it would cause a small acceleration or change in velocity. A larger force acting on that same object would cause a larger acceleration. We know that force is directly proportional to acceleration. If you push a truck here, or a car with the same force, assuming these men are able to be exerting the same force on each of these objects, the car has the smaller mass, the truck has the larger mass. Which one accelerates faster? Well, if they're exerting the same force, the object that has the smaller mass accelerates faster than the truck with the larger mass. So therefore, mass is inversely proportional to acceleration. Now let's look at the relationship between force and mass. Okay? It requires less force to accelerate a low mass object here. Less force is required to accelerate this some amount than it would be to accelerate this higher mass object the same amount of acceleration. So force is directly proportional to mass. So I wrote these different relationships down that we just discussed, that force is directly proportional to acceleration, that mass is inversely proportional to acceleration, and that force is directly proportional to mass. So if force is directly proportional to mass, and force is directly proportional to acceleration, and mass and acceleration are inversely proportional, this is the formula that we come up with. Force equals mass times acceleration. The sum of all the net external force is equal to mass times acceleration. So let's try a little problem with this. This is a really easy problem. Space shuttle astronauts experience accelerations of 35 meters per second squared during takeoff. What force would a 75 kilogram astronaut experience during an acceleration of this magnitude? So let's write down the variables that we know. We know the mass of that astronaut is 75 kilograms. We know he's accelerating at 35 meters per second squared, and we would like to find the force. What is the force? Next, we can write down our relationship. The sum of the net external forces is equal to mass times acceleration. So this is pretty easy. We can simply plug and chug values in. We know that the force he's experiencing is equal to 75 kilograms times 35 meters per second squared. And I get an answer of 2,625, but I only have 2 sig figs that I can use in my answer. So I'm going to need to round that to 2,600 kilogram meters per second squared, right, are my units. And remember, our SI units for force are kilogram meters per second squared, which is equal to a newton. So 2,600 newtons is the force that he's experiencing. So just a reminder, our units for force are the newtons, kilogram meter per second squared. And a little note here when solving problems, sometimes it's easier to break the equation for Newton's second law into components. Remember, the sum of the net force is equal to the mass times the acceleration. If we're breaking that down into components, the sum of the force in the x direction is going to be equal to the mass times the acceleration in the x direction. The sum of the force in the y direction is going to be equal to the mass times acceleration in the y direction. If our net external force is 0, then the acceleration would be 0 as well. And that would mean that our velocity is constant, either at a constant velocity of some magnitude or at a constant velocity of 0, one or the other. So just a quick review. Newton's second law, know what that is and the relationship between force, mass, and acceleration, and obviously memorize that equation. That's an easy one. Advanced idea, explain conceptual challenges on page 138, or ask your own questions, make your own problems. Anything we've discussed or looked at, look into more questions about how things work or why things are the way they are, and I look forward to seeing you in class and seeing what you come up with.